In this video, we present pen rolling, the rotation of a pen around its longitudinal axis, as a supporting input modality for pen-based interaction. We implement rolling-based interaction techniques using a Wacom tablet and a Wacom ink pen. The rolling of the pen is tracked by a Vicon real-time 3D tracking system to ensure highly accurate data. A real application might instead rely on tablet hardware for roll detection, such as a Wacom 6D Art pen, at perhaps a slightly reduced fidelity. Prior to incorporating pen rolling into pen-based interactions, we conducted 2 experiments to investigate the properties of rolling a pen. Experiment 1 determined the thresholds that separate intentional pen rolling for the purpose of interaction from incidental pen rolling caused by regular writing and drawing. Experiment 2 determined the usable range within which a user can comfortably roll a pen, and the easily discriminable rotation that a user can intentionally roll a pen in a timely and accurate fashion. The rolling cursor is designed to visualize the rolling angle of a pen. If pen rolling is identified as incidental, the system shows the simple rolling cursor to indicate that rolling-based interaction techniques are not activated. The black cross shows the position of the pen tip, the red rolling line indicates the rolling angle, and the blue sector indicates the angular threshold for identifying incidental pen rolling. Once pen rolling exceeds the thresholds of rolling angle and rolling speed determined in Experiment 1, it is identified as intentional pen rolling for the purpose of interaction. The full rolling cursor will fade in, indicating that rolling-based interaction techniques are activated. Whenever the pen tip leaves the tablet, rolling-based interaction techniques are deactivated, and the simple rolling cursor is shown again. Object rotation is a common task in drawing and animation applications. However, if the interface relies only on the position of the pen tip, performing object rotation involves separate steps, such as switching to a rotation mode and dragging a corner of the object. Employing pen rolling allows a user to rotate an object in a more fluid manner. The user directly rotates the object by rolling the pen. Clockwise rolling of the pen produces clockwise rotation of the object. The object rotates and moves as if attached to the pen tip. This technique provides a consistent relationship between the perception of object rotation and the action of pen rolling, ensuring a high degree of stimulus-response compatibility. When reading a document on a tablet PC using the typical pen-based interface, a user has to click the arrow on the scroll bar to scroll up or down. This requires extra pen tip movement and diverts the user's attention from the reading process. Associating pen rolling with standard mouse wheel behavior allows users to scroll down or up by rolling the pen. For example, we map clockwise pen rolling to scrolling down. A user can make an annotation with the pen tip and then immediately scroll down or up by rolling the pen. This technique allows a user to navigate a document without any pen tip movement, thus maintaining interaction focus in the reading process. When browsing a map using a typical pen-based interface, a user pans by moving the pen tip and zooms in or out by clicking the on-screen buttons. Since panning and zooming are performed separately, user attention can be easily diverted. Associating pen rolling with zooming allows a user to zoom in or out by rolling the pen. In our system, we associate counterclockwise rolling with zooming in. This technique allows a user to pan and zoom simultaneously, maintaining the focus position during the task. In a curve editing task, the typical pen-based interface requires a user to separately adjust the position of a control point and the direction of its tangent vector. Combining pen rolling with both tip pressure and position allows a user to control 4 degrees of freedom simultaneously. Given a control point of a curve, a user can change its position by moving the pen tip, adjust the direction of the tangent vector by rolling the pen, and increase the magnitude of the tangent by applying more tip pressure. Mode selection presents a usability challenge for pen-only systems. A typical method of switching mode is to click on-screen menus and icons. However, this introduces a round-trip travel problem which slows users down and diverts attention from the actual tasks at hand. Pen rolling provides a localized, one-handed, and button-free approach for mode switching by mapping different rolling angles and directions with different modes. For example, in a drawing application, different rolling angles are mapped to different drawing tools. Rolling the pen with a certain angle selects the corresponding tool. This technique allows a user to switch modes without moving the pen tip, eliminating the round-trip travel and maintaining interaction focus on the task at hand. We now show the system being used to create a simple drawing.